Hello everyone, welcome to a new series on my YouTube channel called Mastering Infrastructure as Code. This is part one of the series, and in this series we will be looking at Terraform and how we can leverage infrastructure as code with Terraform to deploy AWS resources to the cloud. So let's look first at what exactly infrastructure as code is. So it is the process of provisioning infrastructure like AWS resources through software to achieve a consistent and predictable environment. Now, the reason why we would want to be learning infrastructure as code and Terraform is in my previous videos, I have made all of the AWS infrastructures, like all of the AWS resources with the AWS Management Console. And this is fine, completely fine. But if I want to spin up the same environment, exactly the same how it was, but I deleted it, I cleaned up all of the resources, then I need to go and remember in what state the environment, like in what state the resources was. There's always resources that I forget to spin up, like configurations on subnets and security groups and routing tables that are really nitty gritty. Yeah, you just forget what the overall environment looks like. And the thing is, with infrastructure as code, you have the environment configuration saved and you can source control it. You can put this code in GitHub and you can source control it. Next up, looking at Terraform, which is what we'll be using to deploy our infrastructure as code. Terraform is an open source infrastructure automation tool, and it can be written using HashiCorp configuration language or just plain JSON. Terraform is a declarative language as well. Now, next up, let's look at some few benefits of infrastructure as code. So as previously mentioned before, it is amazing for reusable components, and it also works great with any automated deployment process. It is also great for any repeatable process that you would want to repeat multiple times, and it provides a really consistent environment. So there would never be something that you would not know about, or something that you would be forgetting. And it also provides you with a documented architecture. Now let's continue by looking at what we are going to build today as an example Terraform configuration. So we are going to deploy to the AWS cloud, specifically in the EU North 1 region. And in that region, we are going to deploy a VPC with one public subnet and an EC2 instance running on that public subnet, which has Nginx configured on it as a web server. So Terraform has three object types: providers, resources, and data sources. Now, providers are the provider plugin that you would want to use. So for example, AWS, you would need to specify your AWS user access key and secret key, as well as the current region that you're on. And then resources are any resource you get from your provider. So this can be, for example, an EC2 instance or a database. And then the data sources are just more information about your provider that you would want to use to spin up some of your resources. Something like an AMI that you would want to use to spin up an EC2 instance. Quickly looking at the Terraform syntax that we'll be using. So first you would need to specify your block type, which is one of these: a resource, a provider, or a data source. And then as well as the label name, and then inside of the curly brackets, you can have a key and a value for that key. So let's look at an example of how you would spin up an EC2 instance using this Terraform syntax. So first of all, we are specifying that we want a resource and that we want an AWS instance as the label. This is how you would specify that you want an EC2 instance. And then for the name label, so this is how you would identify this resource throughout the rest of the Terraform code. We would specify web server, and then inside of the configuration, we specify name, which is equal to web server. So this would be the name of the EC2 instance. All right, so heading on to deploying the example configuration. Here is where you would install Terraform. Here you can choose macOS, Linux, or Windows. And then I will put the link for this page in the description. But I have already installed Terraform, so I'm just going to hop over to VS Code. Right, so in VS Code, we can open up a terminal and then just confirm the installation. So you just do that by running Terraform and then version. So here you can see the latest version that I'm on, version 1.8.5. And then let's look at the Terraform main file that I've set up. So here is the provider where you specify the access key and secret key for your user, as well as the region that we're on, so the EU North 1 region. Now, I would advise to never use or never store your AWS secret keys and access key just in plain text. Always use something like an environment variable or a credentials file. We're just doing this for example purposes, and these access keys and secret keys will already be invalid by the time you're watching this video. So here we are creating a provider, and then here we are creating a data source. So it is an AWS SSM parameter called a Amazon Linux 2. And here in the parameter, we specify a path to the latest Amazon Linux AMI that is available in your current region. And then next up, as part of the networking and the resources, we spin up an AWS VPC called My App, and we associate a CIDR block, and then we enable DNS host names. Heading forward to the internet gateway, here the internet gateway is also specified and then with the same name. So it is important to know that it is better practice to name your resources for what they are for rather than just giving them a unique ID, because they'll anyway be given a unique ID once they're spun up. So that's why I just say they're all for my app. And then here we associate the internet gateway with the VPC by specifying AWS VPC and then my app, which is this label, and then .id. That's how we associate the internet gateway with that VPC. And then here we create an AWS subnet, and then we specify a CIDR block as well as a VPC ID. We associate a VPC to this public subnet in the exact same way that we did for the AWS Internet Gateway. And then we set map public IP on launch to true, which means that when the AWS EC2 instance is spun up on the subnet, it automatically gets a public IP address associated with that EC2 instance. Then moving on to the route table. Again, we associate the route table with the VPC by specifying the VPC name and then the ID. And then we add a route. So this is a default route where we specify the CIDI block. And then the gateway ID, which we specify here in the exact same syntax. And then next, we want to associate our route table with our single subnet. So here we create a AWS route table association, and then we call it app underscore subnet 1. And then we specify the subnet that we want to associate as well as the route table ID that we want to associate. Again, specifying the resource and then the IDs of the resources. So next up, we are going to create our security group. This is our security group for our Nginx web server. So that's why we specify a name, Nginx, and then underscore security group. Again, we specify the VPC that we want to associate, and then we create ingress and egress groups. The ingress for traffic come into the web server and egress for traffic going out of the web server. So here we are specifying port 80, which means HTTP, and then the protocol is just TCP, and then the CID block is specifying from anywhere. And then the egress group also specifies internet access from anywhere. So heading on to the AWS EC2 instance that we are going to create. Here we specify the AMI, and this is the data source that we created earlier, and then we just say .value. So this will retrieve the latest Amazon 2 Linux AMI in the current EU North 1 region. And then this non-sensitive is just a function, and we will be covering that in a later video. And then the EC2 instance type is T3 micro, just to keep it relatively small to stay in the free tier. And then the subnet ID, we just associate that the same way that we've been doing by specifying the name of the subnet and then saying .id. And then in the VPC security groups, this time it is group IDs because it is specifying, or it is expecting rather, an array of security groups, but we only have one. So it is an array, but we only put the one down. And then here we specify the user data. So this is basically what is going to happen once the EC2 instance is started up for the very first time. This script will execute. And then if you're not familiar with the syntax, it's just a simple syntax for specifying a script that is declared inline. So for an inline script. So then to actually run this environment and deploy it, we'll be looking at some Terraform commands. So to look at the Terraform CLI and what it can do, you can either run Terraform and then -help to see more information about what you can do in the Terraform commands, or you can just do normal Terraform and it will show you the exact same thing. So scrolling just a bit up, it'll show you the Terraform and then just the options, so any global options, and then the command that you want to run, and then any other arguments. So we are going to initialize the project by running Terraform init. After the Terraform command has been successfully executed, you'll see this green text over here stating that the Terraform has successfully been initialized. And then you'll also see here in your folder that these two files have been generated. Next, we are going to run Terraform plan to plan out your configuration. But we are going to save the execution plan in a file. So we specify the -out argument, and then we specify a file. So just standard practice is to end the file with .tf plan. So what this will do is Terraform will look at your current configuration, and it will look at the differences between your current configuration and what is in your main .tf configuration, and it will look at the differences, and then it will create a plan for you based on your desired configuration, which is in your main.tf. So if you run this tf, so after we've ran the Terraform plan command, here you can see everything that Terraform will add. All of these green pluses indicate what Terraform will add. And then here at the end, it says to perform exactly these actions, run the following command. So Terraform apply will execute the plan. So we can just take the Terraform apply command, that we can just copy it, and then we can paste it in, and then we can press enter. If we didn't create a Terraform plan and we just ran Terraform apply, it will have shown a plan for us, and then it would have shown a prompt for us as well, asking us, is this the plan that we want to execute? And then this Terraform execution will take a while, so we'll be back once it is completed. All right, welcome back. The Terraform configuration has been successfully deployed. Here you can see it added 7 resources, it changed 0, and it destroyed 0. So now let's head over to our AWS Management Console, and we can confirm that the configuration has been deployed successfully. Let's look at our EC2 instances. Let's just click on the only one that is running. After that, copy the public IPv4 address, and then open a new tab and paste it into the tab. So here you can see that the web server works fine and you've deployed your first Terraform environment successfully. Lastly, let's go back and just clean up the environment by running Terraform destroy. So this will clean up everything that you have created in your Terraform configuration. So after the Terraform destroyed has executed, you'll see everything that the Terraform destroy command will remove. So in the real world, be really careful when running this command. We are just running this command to save money on the AWS resources and to keep in the free tier. And then you would have to enter yes to confirm you want to run Terraform destroy and remove all of these resources. After the Terraform command has finished executing, you can go back to your AWS management console and then just refresh the EC2 instances. And then here you can confirm that there are no active instances running, which means the Terraform command worked. That is all for this part 1 of Mastering Infrastructure as Code series, and I'll see you guys again in the next video.